Hi guys, this is the third video in my Formula Student series. Today we're going to be following on from the last video in which we made a nice schematic in KiCad. Now we're going to be turning that into a PCB, and I'm going to show all the steps from laying out components, doing a board outline, routing traces, fixing any issues, and then even ordering the PCB. So let's get right into it. Right, so to get started on the PCB section, click on this, which will open the PCB editor for the project, and as you can see it looks like the schematic editor but in dark mode, which is basically what it is. This is just blank at the moment, so then if you click on this, this will bring in all of the footprints that we've assigned to all the symbols on our schematic. So clicking on that, if you haven't already annotated, which you do with this button, I normally don't until the end, then press annotate here, and what this will do is this will give all the components numbers. So right now they'll just all say R question mark, C question mark. Once you've pressed this, it'll number them, and you can decide how you want them numbered, the order it goes through, whether to start at certain numbers, things like that. What I often do is, once I've finished the PCB design, you can then run it so that it annotates them based on the component's positions on the PCB instead, which often looks a bit nicer. And then you can re-reference the schematic to that. But for now we'll just press annotate, update. Here's all our components, all the footprints, and you can see there's 3 warnings here, all to do with U5, and basically that is because if we click on this to go back to the schematic, U5, which is the 4024 counter, it's missing as pins 7, 10, 13, which is just because it's a crap footprint. But in a future video where we cover importing footprints and also making custom ones, we will make our own 4024 footprint that is a lot better. So let's head back to the PCB, and the first thing I always do is just spread out the components that we've got into little groups. So this particular project is very easy to group because we can separate every 4026 along with its display, and we'll get the decoupling capacitor for them too. One thing that I'm going to show you, which is very useful, is that although on the schematic every decoupling capacitor is next to a chip, all of the capacitors are actually just connected between 5V and ground. So over here, it's quite hard to know which capacitor is meant to go with which chip, because every capacitor goes across the same 5V and ground rails. So what you can do is sort of go into a split window view, and now when you click on a component, it highlights it on the schematic, which is very useful. So now I've spread out every 4026 and its respective display. I'm now going to find which decoupling capacitors go with each one. So you can see when I click on this here, highlights it on the schematic, and it says it goes with U8. So U8 is down here, so I'll pop that one with that, and I'll repeat this for every capacitor. Right, now that these are all a bit spread out, I'm going to go to one of these little groups, and I think I'll probably just put the display directly below like this, or I might go above. I'll have a little think, and then I'm going to copy that for the other 6 digits. One thing to note is that you can't copy and paste in the PCB viewer, because so for example this footprint is for U7, so if I copy and pasted it I'd have another U7 which would try and connect to the same 4026. Something else you can do to tidy this up a bit and just get rid of a bit of text is these are all the different layers. So you've got copper, and then you've got silkscreen, things like that. Edge cuts, that's going to define the outline of our board later. We've got F and B fab. If you click the little I, you can get rid of that, and that's not silkscreen, that's not a layer that actually gets made, so it just clears up the view a lot. So I'm going to go for the display below, because you can see these lines are called the rat's nest, and they show which pins need to connect to which other pins once we get to adding tracers on. And the majority of these are on the lower half of the chip, so I'll have to do less. The tracers will probably be easier to do if I put this at the bottom, because then they won't interfere with the tracers that are going on at top. For every chip I'm using, 4000 series and 74 series particularly, 5V and ground are in the top right and bottom left pins. So what I want to do is, if I press R while I've got this capacitor selected, I can rotate it like that and I can put it there. But the problem with it there is that it's on the front and it's in the way of the chip. So what you can then do is press F. That then puts it on the back of the board. So you'll see later on when we enter the 3D viewer, but basically I'll have the board upside down, solder all these components, all the decoupling capacitors, and then flip it back round to solder all of the sockets. And most boards nowadays are at least 2 layers, so it's a good thing to get used to, is making the most of the fact that you can put components on the back. If you're manufacturing them, if you're assembling them yourself, that's not really a problem at all. As long as it's surface mount, you can't really do through-hole things on both sides. But if you're paying to get the board assembled, often they'll charge quite a lot more for double-sided assembly, so that's when you'd then try and keep everything on one side. But we're better than that, we can make our boards ourselves. Another thing is, if you're struggling to get the components to sit where you want them to, up here you can change the size of the grid. So that's how big, where the cursor snaps to. So you can see I've got this set to 0.01 inches at the moment, and I can sort of put this where I want. But if I set this to 0.1 inches, then now it jumps around, which is usually pretty helpful for layout. So sometimes you'll want to use imperial and sometimes you'll want to use metric. So in this case I'm going to stick with imperial because these chips are imperial sizes. So these are the kind of chips that you could put in a breadboard, and the distance between the pins is 0.1 inches. So I'm going for 0.05 inches just to give a little bit more freedom. This capacitor's done something that components seem to just do sometimes while you're trying to drag them around in the PCB editor, which is that the reference point for moving it has changed. So you can see on this capacitor, when I drag it, I'll zoom in a bit, the cursor is on the middle of the capacitor, which is what I want. But over here, the cursor is now on the bottom pad, or it can be on the top pad, but I can't get it to go in the middle. So if you find this has happened, what you need to do is right click, special tools, move with reference, then put the cursor on the middle because that's where you want the reference to be. And then now you can move it around as you would expect it to behave. So now I've got all 7 digits down here. I'm going to make sure they're in the right order. So I sort of want the opposite order to the way that it's been drawn before. I want the least significant digit on the right, so the input from the clock circuitry will come in on the right, so that will be the fastest digit, all the way up to the left digit, which will be the day counter, the most significant digit, and the one that changes slowest, with a period of 1 day. There we go. Now I'm going to build up the clock section of the circuit next. So just looking at that part of the schematic, we want the 7/4 series AND gate, which is U2, then U1 for the 4020, and the 4024 is U5. We also want X1, which is the oscillator, and all of their respective decoupling capacitors. So I've got those components here now. Again, I'm going to be looking at the rat's nest when I try and come up with an arrangement for these. So we can see on the schematic the flow. I don't really care about the oscillator because that's just connecting to the 4020 with a single wire. But the AND gate and the 2 timers here, the 2 counters here, they've got quite a few connections. So I'm going to try and get it so that what you really want is you don't want many crossing, and you want them to go from the right hand side of the chip on the left to the left hand side of the chip on the right. So just dragging it around here kind of lets you see whereabouts you want it. It looks like more of the connections are on the left hand side of U2, so I'm tempted to put U2 on the right, and U2's the AND gate, so that's okay. Then U1, if we put U1 on the right as well, then we can try and keep it resembling the schematic, because realistically, wherever we put them, on a board this simple, we should be able to do the traces for them. So then, in that case, it's quite nice to keep the board reflective of the schematic layout. It's helpful for debugging when this inevitably won't work. And then, just to stick with the schematic again, I'm going to pop the oscillator right there. I'm also going to rotate the oscillator because pin right on these sort of dip chips is basically always top left, and you can see here it's bottom left, whereas if I rotate it once, a few more times, now it's where you'd expect, top left, then it goes 1, 2, 3 aren't there, 4, 5, 6, 7 aren't there, and then it goes to 8. This has moved the Silkscreen, which doesn't look very nice, so what I can do now is drag that, press R to rotate, and place it there. So the next thing I'm going to do is I'm going to draw the board outline. That's going to show us how much space we have to work with, and that should then help us arrange the remaining components. So depending on the project you're working on, sometimes the board outline will be the first thing you do. Sometimes you'll be prescribed specific dimensions for the board. Other times you just want the board as small as possible, so you'll do the layout, you'll cram in all the components like this really tight, and then just draw a box around them. And other times you're just making a test board, so you don't really care about the size. And in that case, I would recommend making it 10 by 10 centimeters square, because unfortunately I'm not paid to say this yet, but I would recommend JLCPCB. The minimum quantity of PCBs you can order is 5, and if you're ordering 5 PCBs, the price is the same up to 10 by 10 centimeters, or technically 4 by 4 inches. That's why I'd recommend that size. You don't save any money by going smaller, just for a test board. So we'll start by drawing the board outline. What you want to do is select the edge cuts layer, and I'm going to do it off the page and then drag it on. We will use a grid of 5mm, the biggest metric grid, and what you could do is just draw a box and say job done, but I can tell you now this will look shit. So what you want is round edges. So start with this and draw a line that's 90mm long, then cancel. Then if you can see the grid, hopefully it shows up in the video, go 1 dot right, 1 dot down, and now do a 90mm line down. And do the same thing, so you basically draw a square with missing corners. Then what you want to do is select the arc tool, and the arc tool will always draw clockwise. That's the most important thing to remember. So the first click tells you the center of the arc, center of the radius of it, and then you can see the second one then selects the beginning of the arc. So if I click up here, if I go this way, it does what I'd expect. If I go this way, see, it always goes clockwise. So you've just got to pay attention to where you place the second click. So if I go clockwise 90 degrees, there we go. Then go right this time because it's going clockwise from it. And now we have a lovely board outline. The one other thing I'm going to add, which isn't necessary, but I think it's always a good idea to have, is mounting holes. So these are footprints that aren't linked to a component, so you can click on the footprint library up there. We're already used to this, so we're going to find mounting hole, and then M3 is the most common. So if you've ever used a motherboard, they're M3 standoffs, they'll use holes this size, and the best one is the bottom one, pad via. So that's because it's got vias, which are little connections between the top and the bottom of the PCB that go through it. They hold the pad on the top and the bottom together, and it's basically just the strongest of all the different options. So double click on that, and then we just want to put it in the corner, so it should be the same dot on the grid that the arc that you've used in the corner was centered on, and that should mean that this edge of the board has the same center as the mounting hole, which means it looks very nice. So then just pop one of these mounting holes on the other 3 corners. Oh, before you do that, actually, what you should do is this ref star star is on the Silkscreen because this isn't reference to any symbol on the schematic. So you can, if we look up here, you've got U11, U10 on the Silkscreen. This just says ref star star because there's no symbol. So what we're going to do is double click on the text and then just uncheck this visible box, which then just hides the fact that this footprint has no symbol associated with it, which isn't a problem. It just looks bad when it says ref star star on the Silkscreen. And that's our board done. So what I can do now is I'm going to drag our components away. I'm going to put the board there, just on the sheet. And now I'm going to, just as a sort of initial provisional layout, place the components onto here. I know it's not centered, they're not going to stay like this. Then what I can do is enter the very exciting 3D viewer, which you can do with the View 3D viewer. And what you can do in the 3D viewer is we can see our PCB, and you can toggle this. So this button will change whether through-hole components are visible or not, and this one will do surface mount. So on the front, the only surface mount we have are this little capacitor and this big capacitor and this little resistor. But if we go to the back, we can see our decoupling capacitors. So let's close the 3D viewer and continue. The next thing I want to do is get the display digits so that they're perfectly centered on the board. So I'm going to move everything else out of the way for now. And the problem that we've got now is that the board dimensions are metric, but the spacing that I want for everything else is imperial. So we're going to try and get the center of the board to line up with the imperial grid that we're using, and then all the components should then line up nicely. So I'm also going to drag these out actually. I'll put them over here. And what I'm going to do is change to the grid I like, which is 0.05 inches. Then select the whole thing, and you can see at the moment I'm just moving it I'm just dragging round one of the mounting holes. So what I want to do is right click, Special Tools, Move with Reference, and I want the very center of the PCB, which I can't select at the moment because now I'm on an imperial grid, so the center isn't correct. So I'm going to have to go back to my 5mm grid, highlight it all, right click, Special Tools, Move with Reference. Then I can select the center and move it around like that. And what I'm going to do is I'm then going to put it at 0, 0. So at the 0, 0 is the top left hand corner. You can see the coordinates of where the cursor is at the bottom of the window. So it says y is x0, y0. If I move right, you can see the x increasing or going negative. And the reason I've taken it to 0, 0 is because when the grid changes, 0, 0 is the only point that will always stay the same. So now when I change to 0.05 inches, 0, 0 is still in the same place. So if I highlight this again, right click, move with reference, and then click on 0, 0, then now when I place this in here, the center of the board aligns perfectly with the new imperial grid, which means now when I highlight all of my display bits, I can drag it in like this and it is all perfectly centered on the board. And we can check that with the 3D viewer. which you enter with Alt-3, you can see our other components off to the side here. And there we go, perfectly centered on the board. So now we can have a think about how we want the other components to fit. I think I'm going to have a think about the USB connector next. So for the USB connector, this right hand side is the front of the connector where the cable plugs in. So we want that on the edge of the board. So I'm going to put it on the left hand side, and we should just be able to have it sit like that. And we also want the fat decoupling capacitor C11 to be close to it. So I'm going to rotate that like so, and that's just going to sit there. And again, we can check in the 3D viewer to make sure it all aligns how we want. You can see some components don't have 3D models, so the USB connector and the 7 displays, all we can see is the footprint. So you can add 3D models, you can make your own, or you can more likely import them from the internet. I will also show how to do that in a future video on this project. Next, let's bring over the timing circuitry. So I think what I'm going to do is get all of these chips to line up. So even though the 4069 is used by this 4026, I think it's probably neater to just put it with the rest of them, because it's only a single line that we're inverting, so it should probably be okay to have 2 wires go off to it and then 2 wires come back. And you can see this is nice because these chips line up vertically with the other ones. And what I can do is I'll bring these down a bit, bring the other ones up a bit, and hopefully it should look quite nice. Let's check that in the 3D viewer. Sexy. All we have to do now is move the reset button and not forget about this little resistor down here, which is for the illuminating the decimal point. So the reset button, I want it somewhere nice and accessible. So I'm thinking maybe just slap bang in the middle at the bottom. Let's see how that looks. You'll see there's a lot of switching between the PCB editor window and the 3D viewer, at least for my workflow. Now we've just got the 2 resistors, so what I'm tempted to do is be a bit arty and put the 2 resistors sort of symmetrical on either side of the switch, so that you can see the progression that mankind has made from through-hole to surface mount, or some wanky shit like that. Just need to rotate this one. You can see how the tracers cross over, so rotating like that will fix it. Then the Silkscreen I want above, so we can just drag that above. Silkscreens, I often set the grid very small just to get them exactly where I want them. That is looking quite nice. This decoupling capacitor's moved, so I'll just bring that back. See, it's done the weird reference thing again. So right click, special tools, move with reference, select the center, there we go. We'll do one last check in the 3D viewer and then we'll move on to the tracers. If a component is bright green in the 3D viewer, that's because it's selected here, so you can see the oscillator's selected. If I deselect that, now it's not green anymore, just in case you start panicking that your oscillator's turned green. I think I'm going to spread the 2 resistors out a little bit further. Yeah, I'm much happier with that. I want to put some cool Silkscreen on this, and there's going to be some Silkscreen to do with those. I'm actually going to shift everything down a bit just to leave a lot of space at the top for a big Silkscreen that says decimal clock or something like that. So with tracers, you might think, let's just get straight into it and start drawing connections. But something that you should always do first is add some fills. A fill you add with this tool here, and basically it's a bit like a trace that covers the entire board, and it connects everything that's on a particular net together. So a net it's a bit like a label or something. So a net is, if you looked here, the net would join pin 3, pin 8 and ground together. And ground and 5 volt are special cases of a net, a bit like a label, where loads of things connect to them. what we're basically going to do is make it so that automatically all of the grounds are connected and all of the 5 volts are connected. How can we do 2? Because we've got 2 sides on our board. If I demonstrate here, on the layers on the right, we're going to select front copper. Then we're going to click add a filled zone. And then now we're going to draw a box, and everything in that box is going to become copper connected to ground. So what I'm going to do is select here, and the first time you click it's going to say what layers do you want it and what net do you want it on. So we want the front to be on the ground net. If you're on the Formula Student team, the convention that I want to try and stick to is ground on the front, power on the back, or ground on both sides in some cases. When I say some cases, this board is nice in that everything's either ground or 5 volts, but sometimes you'll have multiple supplies. I recently made a board with 12 volt, 5 volt, 3.3 volt and 1.8 volt. I don't have hundreds of layers, so I can't make a different layer for each voltage. And also, ground on both sides, especially if you add via stitching, is a lot better for noise rejection, and it's a bit like shielding around your circuitry. But for this we don't care, and most boards it's better to just have power so we can minimise the number of traces we need. So if you click on the corners, and then you have to double click on the first corner you clicked on, single click actually, and now the most important button, apart from the combination of Control and S, is pressing B, which does our fill. So there we go, now it's all red. And if we have a look at some grounded things, this is the ground pin on the USB connector. You can see it's connected. This is the ground pin on the fat capacitor, ground pin on the oscillator. And the reason they're connected this strange way, we can actually change that. If we highlight the fill and press E to enter the properties, then you can see it says pad connection is thermal relief. If we change that to solid, then now it just goes straight onto the pad without the weird little cross. But we don't really want that, because the main reason that would be useful is if you're trying to either pass a lot of current or a lot of heat between the pin and the fill. And most of the time the heat is the thing we don't want, because that makes it hard to solder, because to heat up the pin you also have to heat up the entire ground plane. So apart from in special circumstances, leave it on thermal reliefs, which is the default. Now we're going to do the same thing on the back, so select back copper. You can also toggle between the layers by pressing V. And this time select plus 5 volts. OK. Press B again. Now you can see on the back it connects to the capacitors. For some reason it's not on thermal reliefs, so I'll just change that. Press B again. If anything ever looks weird with the fills, press B. I'll just check that the front one is actually on thermal reliefs. Yes, perfect. That's greatly reduced the number of traces we need to do, which will save us a lot of time and energy and other things. And you might be thinking now, but the whole of the front is covered in copper. Where are my traces going to go? If I click on this, which is the trace tool, and let's say for now I'm just going to join these 2 pins together. So I'm going to go from here up to that. Now when I press B, it moves the ground plane out of the way for my new trace. So that's my answer to your question. The next thing I'm going to do is define some trace widths, because you might have seen that one was very thin. So what we're going to do is click up here and click Edit Predefined Sizes. And then in the width column, we'll do Add. And we're going to define them in mil, not millimeters, mil, M-I-L. That is a 1/1000th of an inch. It's a bit of an old unit, but it's very common in electronics, and it's used a lot more than millimeters or micrometers for trace widths. 10 mil is probably the thinnest you'd want to go, so just in case we need it, let's add that. 10 mil. Then we'll add another one. It's also called thou sometimes, but if you've got a particular PCB manufacturer, like JLCPCB, you can go on their website and they will say, this is the thinnest trace we can make. And they'll also tell you loads of other things. They'll say, this is the smallest hole we can drill, this is how close your traces can go together, stuff like that. But 10 mil, you should always be fine. Then I'm going to make a slightly thicker one, which is going to be 16 mil. I think we'll probably use that for all of our signals. Then I'm going to do 25mm, which we're going to use for all of our power. So we're not going to have much power because the planes have already done it for us. Normally you want power traces to be thicker. Then press OK. And we can do a power trace between these two. So if we select our 25mm, select trace, and you can see now that's a much more reasonable thickness. What I'm going to do, the grid is quite big, so a smaller grid usually helps with this. I think with trace drawing I usually use 0.01 inches. And I'm going to do this trace, but then I'm actually going to change it. So you can see that's what we want, 5 volts. And now the line, the rat's nest, has disappeared, which is good. But there's actually a different way of doing this, which is to connect this pad to the back side of the board, because don't forget the entire back side is connected to 5 volts. So the way that we can do that is we can have a trace that comes out to the side and then just stops here. And you might be thinking, that's a bit weird, that doesn't connect to anything. Then what we want to do is select via here, freestanding via, and click on the end of that short trace. And now you can see it already says 5 volt. And what that does, hopefully we'll be able to see in the 3D viewer, is it connects this top pad, which is the positive of the capacitor. It gives that a direct electrical connection to the back of the board, which is 5 volt. So if you've got a through-hole component, that will automatically, because the pin of the component it goes through the board, through hole, so it lives on the front and the back. That can connect to whichever side it wants. Surface mount just lives on the front, so we have to basically give it its own little hole to bring the signal round to the back of the board. And what I'm going to do, because this capacitor's fat, I think it deserves 2 connections. So I'm actually going to do the same on the other side, but that's not a convention or anything like that, so I wouldn't worry about it too much. Next is the decoupling capacitors. They're all the same, but I'll just show it for the oscillator and then repeat it for the others. So let's switch to the back layer, add a little trace coming out, which is then just going to stop down here. Pop a via on that, press B, ta-da! That now connects through to ground. I'm now going to repeat that for every other decoupling capacitor. There we go, that's all the vias done for the decoupling capacitors. The rest of the components that are connected to a rail, almost all of them are through hole. I've just spotted this resistor, so let's give that the same treatment. And that should now be everything, because all the other components are through hole, so through hole is basically a component with the built-in via, is a funny way of thinking about it. Next, let's actually do some proper traces. So I'll start with this one down here because there's a nice amount of space around it. On the front layer, we're going to select Trace Tool. I'm going to change the width to 16mm, and we're going to run along here. With these ones, when you're doing the trace, when you click, it locks up to where you've clicked. So if I know I want it to definitely come to here, and then I want a forbidden right angle, then I can do that. But that's the one thing I'd say, whether you're on the race team or not, never put a right angle in your layout, or you'll be very heavily judged. So that's the kind of thing I'm thinking of. You can even use the 3D viewer to check your traces, so I can have a look at that and think, does it look weird? No, that looks nice. So let's just continue doing things like that. These 2 pins want joining together. Sometimes what you can have is, so for example, this line up here, I don't know which pins that's connecting. Is that multiple pins? You can click on this, which then bends them. So now you can see which pins are actually connected together and which aren't. So that's just a useful thing to be aware of. I'll head up here next. The two shield pins of the USB want grounding. Well, they don't want grounding, they want connecting together, sorry. So a change of the footprint could stop that from being a requirement, but for now I'm just going to do what it wants and join them together. Now, it's inevitable at some point that some traces will need to cross, so the order of priority for traces is usually the things that matter most are high power signals or high frequency signals. Once those are done, using vias for low speed stuff doesn't matter too much. What I'm actually going to do is go in the order of signal progression, because this is the highest frequency at 4 MHz, and right the way over here we've got 1 day period, so who cares if that has to go through 100 vias to get across the board, because vias are basically, they're not ideal for signal integrity, but if it's not a critical signal, using vias is fine. So let's do this one next. This is the output of the oscillator. We're going to go down, along here, and then up. And you can also change the traces once you've done them. So I want this to come out at the left of this pin. So I can just drag that like so. And over time, you'll get used to what movements will make the trace do what you want. It's quite a strange thing when you first start trying to manipulate the software to do what you want, but you do get used to it after doing a few boards. One thing I'm going to mention is that the rat's nest only shows, each line on the rat's nest just shows the closest 2 points that are on the same net. So you can see if you follow this line from pin 11 goes to pin 2, and then another line goes to pin 6, and another line goes to pin 1. So what you can do is click on one of them, and then it highlights all of the other pins that it has to connect to. So you might not necessarily go in the order of the rat's nest. I might come down here to that one and then have a line that comes off this to that, something like that. So just another thing worth bearing in mind. You can see here I'm going from pin 12 on the left to pin 1 on U2, and what I can actually do with a trace this narrow is I can actually squeeze it between the pins, which is quite a nice way of avoiding having to switch sides. You can see I'm quite a big fan of traces that run in parallel. I just think it looks better. There's not really any reason to have different spacing like this. It just looks bad for no reason. Because these are through-hole components, it makes going to the other side very easy. I don't even need to use vias, so I can just select back copper and then draw the trace like I already have been. And because it's on the back, it can just cross over anything on the front, anything red. Usually I'd try and put as many traces as possible on one side, on a simple board like this, so put the majority on the front, and then anything that needs to be on the back, put on the back. But also, especially if you've got through-hole like this, you don't want traces that constantly swap sides, because they're hard to follow and the signal integrity is not perfect. If you've got a trace, even if you're using surface mount, if you've got two components on the front and you can join them with a trace on the back, don't do a bit on the front, then switch to back, front, back. Just switch to the back at both components and run the whole trace on the back. Makes it a lot easier to follow. Sometimes starting at one end or the other of a particular connection can help also get the software to do what you want. So I don't really like this. So what I can do is come out the top of this one instead, and then get it to do what I want a bit better. One thing to be careful of sometimes is you want to avoid long runs of a trace on the front and a trace on the back running together. There's specific scenarios where you want that, but most of the time it just creates an impassable wall where you can't run a trace on the front or the back to get past it. So that's just another thing to look out for. You can see sometimes you end up with just a very messy trace, but usually it's better to just get the two pins connected and then you can start to clean it up a bit. As you can see, the connections between each 4026 and the display are the same, so there is actually a plugin that you can use to copy layouts, but because of the way that the schematic's been done for this board, we can't make use of that, unfortunately. But in a future video where I show how to make a schematic properly, then I can probably also demonstrate that tool and how it's yet another advantage of not just rushing things like we have. I'm still going to try and get the layout to match on all of these though, so I'm going to do one and then see if I can just mimic it on the others. A big grid usually helps with getting layouts to look the same. So you can see I'm probably a bit too obsessive when it comes to getting traces parallel and nicely spaced apart and things like that, but I don't think there's anyone that does this kind of thing that hasn't got a bit of that in them, so let it out. So I just tried something, and you can actually copy and paste traces, so I'll show you what to do. If you select every part of it, Control C, Control V, paste it off to the side, then press E to enter the properties and change the net to no net. Now you can drag that to where you want it to go, press B, and the net will automatically change to join onto the pins that you've connected it to. Quite nice. If you want to select lots of the same type of thing, there's a selection filter down here, so if you tick all items, turns them off, then you can select tracks, and now if you draw a big box, all you get is traces. So I want all of them except this fat one. So what I'm going to do is highlight from right to left to get all of those, hold shift, get the last ones, copy, paste it to the side, and let's see if I can properties of all of these. There we go. Mixed values net. So then just do no net. Okay. Now they're not trying to link anymore. Then drag this all the way over to here, which is where we want it to go. For some reason it's got a strange offset, which I think is to do with the reference, so just make sure you're dragging it from the end of one of the traces and then it will stick to the grid how you'd expect it to. Then press B, and yeah, it works. That's quite nice. I've just learnt something new. So I'll delete these ones, and I'm going to do that for all 6 remaining digits. Of course, with a lot of layouts you don't have the luxury of being able to just copy and paste between parts, because there's not many patterns in a lot of circuits, but for this particular one I can do that, so I'm going to. Now I'm going to add the traces that join each of the 4026s together. That's the reset line, which you can see goes along all of them, and the counter, which comes out of one, flows into the next one. Using this selection filter a lot of the time is helpful, so it's quite easy to accidentally move components while you're doing traces if you've got a lot, and either just selecting tracks or maybe deselecting footprints is a very nice way of stopping that from happening. Right, not too many to do now. You might have seen some new lines appearing on the rat's nest, Don't worry about those, I will explain those at the end. For example, this one linking 5 volts and 5 volts. Why do we need those? We've already done the planes. I will explain. So, right now I've got a strange issue, which is that these two pins are clearly connected, but there's still a line on the rat's nest for them. And that's because at some point during the copying and pasting, this trace hasn't changed its net. So it isn't actually connecting these two pins. So what you can do is press E to enter properties. And then what I actually want is, well, let's check. This is U16 pad 13. That's the net that I want, U16 pad 13. So press E, net, and now find U16 pad 13. Change nets. And there we go. It's fixed it. Press B for good measure. So this looks like somewhere where we might need a veer. You can see blue would still be good to cross over here, but then we need red to cross over this one that we've just fixed. So you can see a veer might fit there, or it might go there. I think we'll probably put it here and move this blue one if we need to. So let's go blue trace, and I'll explain what a veer does. Let's see if we can pop one there. No. So what a veer does is it's basically just, so these yellow circles are mounting their holes that the pins or legs of the through-hole components are going to go through, and they're plated through holes, which means they connect to the front and the back, and you put your pin through it, put a load of solder on, that holds your component there. So what we can do is basically make a small version of those to just send a signal from front to back. We're not putting anything through it, but it's still plated, which means there's copper in between the two layers, so it creates a direct connection between the two layers electrically. So if I just drag this out the way for now, put that there. There we go. Now when I press B, it's going to clear the fill on the front out the way. I can switch to front layer, and then I can go up and along just like that. And using a veer really is that simple. I'm just going to tidy it up a bit now. You don't have to worry about things getting too close in the software, because the software has defined limits which you can change if you want, the design rules which prevent that. So I can't put this veer somewhere where it's going to connect unintentionally. The software just won't let me. Here is a good example of how the rat's nest just shows the closest connection. So this is the reset button. They come up to, or that comes up to this pin, but that also connects to all the others. So you can see if I add a trace here, you can see it actually connects to all of that. So you don't necessarily have to go the way the line shows. You could go up a different section. Right, now all that's left to do is these strange ones that have mysteriously appeared. And the reason they've appeared is, for this one, if we switch to the back layer, you can see this 5 volt pin connects to the 5 volt plane, the fill, which is what we want. But this fill, because of the traces we've added, has been chopped up, so now it's just on its own little floating island. So despite it saying 5 volts and being connected to a fill, this fill isn't connected to the rest of the fills. So there's two ways you can fix that. Sometimes you can move traces around a bit to let this fill spill over to where you want it to go. However, this one looks completely trapped, so then the other thing to do is sort of basically just do what it's suggesting and add a trace in. I probably won't go between these two pins though, because you can see we've got blue and red close together, it's made an impassable wall. So what I'm actually going to do is go to this 5V pin down here instead. So we'll go on the front here, and it's power, so I need to change to 25mm. Then just drop down like that. And that's fixed the issue. Now it's created a big area here that isn't grounded, but it looks like that's not an issue, so that's fine. Now we're just going to do the same with the other ones. Because they're all issues with the fills, they're all power, so we're going to stick with the 25mm tracers for all of them. In this case, it's a surface mount component, so what I'm going to do is, it doesn't exist on both sides, so I'm going to have to add a veer. So I'm just going to pop one here, right in the middle of the plane, which has connected to ground. So what I do is right click, press E for properties, select 5V, because I want a 5V veer instead. There we go. Now on the red, because I can't use blue because there's a trace there, so on the front we're going to go from that veer up to here. It doesn't need to go to the pin, because you could use another veer here, but I am going to take it to the pin because the fewer veers the better. I'm also going to move this veer slightly so that the trace is nice and straight. There we go, fixed that one. So this one is the same thing again. You can see this big floating island this time here. So we're going to do the same thing. We're going to put a veer, we can put it anywhere for now and move it later. Then switch to blue to get out of the way on the back of the board and pop the trace there. Again, I'm going to try and keep this trace straight because it looks a bit nicer. So I can put that there, press B, and that's fixed that one. Next, there's a very big floating island here, which is also supposed to be ground. Now the only thing that's actually connected to this ground plane that matters is this ground pin down here. So it's probably better for our fix to be somewhere close to that as opposed to up here at the top where KiCad's decided to draw the line. Now there isn't really a nice accessible ground plane anywhere very close, so I'm actually going to head up to the top and link the two ground planes here. Before that, what I'm actually going to do is move this veer slightly that we did earlier, because it creates a thin strip of ground plane here, and we want it to be as thick as possible because it minimises inductance, it minimises resistance, and lots of other good things. So same as we've already been doing, pop a veer here, go through. This one is going to have a veer on both ends, and also, yeah, we do want that ground. Head to the back, pop a trace in, pop another veer on the end and press B. Lovely. I'm going to drag it a bit to the side. Do be careful, if you put a veer under Silkscreen, then you've basically got a hole in your Silkscreen and it doesn't look very nice. So I would try and avoid that if possible. And that looks like it's all done, doesn't it? So there's a few things to do. Press B again. Save, of course. We'll check it out in the 3D viewer and see what that thinks. Oh, doesn't that look nice? We can see our veers inside the chips there. We'll head over to the back. Ooh, nice. What I'm going to do now is run something called the design rules check, which basically just tells us if there's anything wrong. So that is this up here with the list and the tick. Run DRC. Wow, nothing wrong. That's actually annoying because I can't show common issues. But it's a bit like a compiler. You've got errors that are critical, warnings that are less important. Yeah, if you're on the race team and you've followed this and you've got errors and you're not sure what to do, just message me on Teams. Otherwise, leave a comment in the comment section below and I'm sure people will help you out. Okay, so probably all that's really left to do is the silkscreens I wanted to add. So speaking of silkscreens, I did want to rotate this capacitor label because right now all the labels on the front except that are horizontal, and the ones on the back are vertical, so, or sort of rotated. So I think I will change that just to make it look nice. So for the Silkscreen, what you can do is you can either do it the simple way, which is to enter text in here, so I can say hello, pop that there, then Alt 3, and you can see it says hello at the top. Or you can use this nice plugin called KiCad. Again, I'll show how to install plugins in the future, but you can probably figure it out on your own. Click on that, and at the top, what do I want it to say? I think probably just decimal clock, and let's make it quite big. Then pop it in. I'm going to go for a big grid just to make sure it's centered, so let's go for 0.1 inches. There we go. What does that look like? Oh, yeah, that's good. I want to add little silk screens under each digit saying what units they represent as well. Or maybe a little box saying millidays and microdays might be nicer, actually. Again, I'm going to use the plugin. The reason for using the plugin is you get these nice bubbles around the text if you want them, and also it gives you access to more fonts. So here I can type in days. Let's go for 2mm font. Oh, it's still a bit big actually. And now what I'm going to do to make these labels wider, hopefully it will let me do it, is put a load of spacers in the side. No, it won't. So then the other thing I can do is to edit one of these, you can't double click, you press on the plugin thing up here, I keep forgetting, is left and right padding. So let's try 30 left and right. It's probably going to need a lot more than that. Hopefully that's a good example of how things can take a very long time. Simple things, if you're a bit overly obsessive with getting everything symmetrical and aligned. But let's see what that looks like. I can tell already it's going to intersect with the button, so we might have to move that. Oh, I do like that. Let's bring the button down slightly. Got to move the traces with it too. There we go, let's see how that looks. I can put the components back on as well. Yeah, I really like that. I'm going to add little labels to say surface mount through hole. I'm not sure why, just might as well. Might label a few chips possibly. I'm going to move J1 and C11 silk screens up to the top because all the rest of them are at the top. And then I'm going to show you something important that you must never forget. Right, so the important thing that you must never forget is to put your name on it. So you never know when you might need to go to a job interview or just show off the board, and it's invaluable to have your name on it as evidence that you've done it, because anybody can buy a board, but of course you're not proving that you've designed it, but at least you're proving that you've gone in the software, put your name on something, and I don't think many people would go through that and then not make their own board. Again, to do that, I can put that on here. Different people have different standards for doing things. What I'm going to do is at the top, I'm going to have the name of the board, which is decimal clock. Then I'm going to have my name with the little copyright symbol, which I'm going to have to copy and paste from somewhere. And then finally, the year, along with, if you're on the race team, UONFS. Like that. For race team specifically, we do have a specific convention that we want, which I'm afraid I'm not sticking to. But as long as you've got the name of the board, the year, UONFS, and your name somewhere, that's the most important thing. Although it would be nice for standardization, so I might make this into the new standard so that I don't have to stick with an old one. Also, it's 2023 now, isn't it? So let's change that. And then we can put that somewhere. I think I'm going to squish it in down here. Let's see how that looks. Oh yeah, I love this. I think I'll move it left a little bit. Yeah, this is great. I'm going to bring J1 labelled down here a little bit, and then I'll show you one other thing that's important not to forget. So the other thing is, if you're ordering from JLCPCB, which, as I say, I recommend, they put a little identification number on the board so that they know what it is if they've got a big box full of boards. Usually, if you don't do anything, they'll just pick somewhere on the board and you'll end up with this ugly number. So what you can do is add some text. We just use the normal text this time. Just do JLC 4 times. And some people don't like that they do this, but what they'll do is they'll then go in and edit the Gerber file, which is how you export this, and they'll put on their little number in place of where you've put this. So what I'm going to do is I'm going to put it probably here. I'll make it a little bit smaller as well. Let's go for 0.8. And that means that their number will be hidden by the USB connector once that's been put on. Save, Alt-3, check it out. I'm going to move the reset label up a tiny bit. This is all just little pedantic things now, which I recommend you do. You should be proud of your work and make an effort to make it look nice. I'm going to run the design rules check again just to make sure I haven't messed anything up as a final step. Now all that's left to do is export this and order it. So let's do that. So the first step to exporting is just click File, Fabrication Outputs, and then Gerbers. Then this is basically telling it which layers we want to export. So for JLCPCB and probably most other manufacturers, you can just leave this all default. And then before you click Plot, which I have just done by accident, you want to select the output directory so you can make it a nice folder. So this is my project folder. I'm going to make a new folder in here called Gerbers. Select folder. Yes. Now do plot, and it'll put them all in there as opposed to just make a big mess in the project folder. Then click Generate Drill Files and just select Generate Drill Files. Close. Now we can go in File Explorer and see if that's all worked. You can see here it's put all the crap that I didn't want on, so you've got the Gerbers and the drill files. But if I then go into Gerbers there, that's everything I need. So the Gerbers and the drill files are basically just simple 2D vector files that tell the CNC machine that's going to manufacture the board because it starts off with just a big sheet of copper. It says everywhere except here, remove the copper. And then it goes in the Silkscreen and it sort of prints that on, that kind of thing. So what we want to do is zip this up, which we can do here. And then we'll go on the JLCPCB website. And you can see you just drag and drop it. So add Gerber file. There we go. That's the board we want. And you can see it's just so cheap, it's crazy. So we want 2 layers. Everything here is default, which is fine. 100mm, you can change how many you want. We just want 1, but 5's the minimum quantity. You can choose different colours for the PCB, so I think I'll probably go for something a bit more interesting than green. The last board I ordered was blue, which does look quite nice. I'm planning on hanging this up in the background of my room, so I might go for white. I haven't had a white board in a while, although I do want to sort of show off the board. The green is sort of normal PCB green, it's not this crazy bright green. I think I'm going to go for blue again, it just looks really nice. Then you can change the thickness of the PCB. Sometimes that doesn't affect the price, sometimes it requires other things to be selected. 1.6 is standard. I wouldn't really ever change that unless you've got a specific circumstance that requires something different. Copper weight, so unless you're making a big chunky like power electronics board or something, you can just leave that default. But if you want, that'll basically give you thicker copper on the front and the back. You can do more than 2 layers, but we're not going to. I wouldn't change the dimensions because it's getting them from the Gerber that you've just given them. If you don't like lead, you can get the lead-free version, or ENIG, which is gold-plated, which is quite nice. I quite like lead though. Then here, remove order number. Select specify a location because we've told them where we want the order number to go. And all of the other options I would just leave default. Then save to cart, and to order it is just the same way you'd order anything else. So hopefully that's all clear, everything I've done. As I say, if you don't understand, you can message me, email me, or you can leave a comment below if you don't have direct access to me. I'm sure other people or myself will be happy to help out. Well, now I've got 2.5 hours of footage to go through, so I hope you enjoy the time I've put into these videos, and the next one will be on how to import footprints, symbols and 3D models from the internet, and also how to make your own. That should be coming out in a day or two probably. Thank you very much for watching. Goodbye.